Welcome back, everyone. In the last video, we introduced this concept of loops in C. We also saw an example of a while loop, and then we saw an example of a for loop, which we didn't cover in as much detail, but same concept, just different syntax. And these loops give us the ability to perform some action over and over again, such as printing something out a specific number of times. And then we saw an example of how we could create an infinite loop that just keeps going forever using this keyword true. And if you've been following along, then hopefully you've set up the Ubuntu virtual machine and have been playing around with what we've been learning in the previous videos. If you haven't, I have a setup video that walks you through every step of the way. And I'll put a link in the video description. But ultimately, my goal is not just to teach you how to write code, but rather how to write good code. And this is not something that can be learned overnight. It's going to take practice and some experience, just like anything else. But understanding what constitutes good code and bad code is the first step. When it comes to programming and writing code, there are really three main metrics that we can use to evaluate the quality of our code. First is correctness. Like, is your code correct? Does it do what it's supposed to do? And this is probably the most important of the three, because if your program doesn't do what it's supposed to, then what's the point of it? Second, we have this idea of design. Like, how well designed is your code? And we'll see how we can start to design our code better by using some of these building blocks, like loops, for example, and kind of tighten up our code. And I would argue that in the previous example of like printing something out 3 times, we could have simply just used printf and copy and pasted it 3 times instead of running a loop. But anytime copy and paste seems like a solution, it's usually poor designed. Why? Well, because what if we wanted to change hello world to something else, like hello universe? Well, now we're going to have to go back in our code and change this on 3 different lines. However, when we used a loop, we would only have to change 1 line. Now, this isn't a huge deal with small programs like this, but what about if we wanted to print this 50 times instead of 3? Well, if we were copying, pasting, you can imagine that this might not be the best idea, because we would have this huge program that has at least 50 lines of the same thing. And with our loop example, we change 1 number and we're done. So well-designed code tends to scale better. It's easier to maintain by you and your colleagues, someone else trying to understand your code, you the next day. And it's usually faster. And really, design is more subjective. 2 reasonable people may disagree with which version of a program is better designed. But you'll see these building blocks and principles that we can use to get a better sense of how well designed our code is. And the last metric is style. Like, how well styled is your code? And this really applies more to the aesthetics of your code. It turns out that in many languages, C among them, the compiler doesn't really care how sloppy your code is. It doesn't matter if you indent inside of these curly braces. In most cases, we could leave out any white space at all, and our program will still compile and run. But the human cares. Other people reading your code care. They care if it's well indented and well styled. You will care how well your code is styled when you pick it up the next day and are just trying to understand what your code is doing. So style really is just the aesthetics of our code. And you'll see in all my examples that I'm purposefully indenting 4 spaces or 1 tab on certain lines, like inside our curly brackets. And I'm putting spaces in specific places, like after my if, but before my parentheses, and after my for, but before the parentheses. And over time, this will become second nature, where you should be indenting and leaving white space. But this is all essentially to better style my code, and to make it easier to read by you and myself included. So correctness, design, and style are these metrics that we will use to help ensure that we're writing good code. And this is going to tie in nicely to these examples of nested loops, or these loops inside of loops. And to do this, we'll take some inspiration from an old school video game that you may or may not be familiar with. But in this game, we have these patterns. For example, these 4 question marks. And we'll abstract this away, and instead of using actual graphics like in Mario, let's just try to represent this in the terminal using actual question marks. So how could we do this? Well, let's hop on over to our virtual machine and see some examples. So to start, I'll open my terminal and I'll change directory into my tutorials directory, and then use code dot to open up VS Code in this directory. In here, I'll exit out of this, and I should probably save it. And I'm going to create a new file, and I'll call this one mario.c. And in here, let's do our normal boilerplate, hash include stdio.h, int main void, more on this in the next video, my curly braces, and my return 0. And if we wanted to represent these 4 question marks, I would argue that I could do something like printf followed by 4 question marks, and we'll give it back a new line. And if I save this and I come run this, gcc-o mario.c, and then run Mario, you can see that we get our 4 question marks. And so this code works, it's correct. But now what if we wanted to print 5 question marks, or 10 question marks, or 50 even? Well, you can probably start to see how this would get really tedious if we had to sit here and count out 50 different question marks. So how could we better design this? And I would argue that we could use a loop. We're printing 4 question marks, or in other words, we're printing a single question mark 4 times. So let's implement this in a loop, and we know how to do this. So I'll just clean this up, and I'll use a for loop, if only because they're a bit more common in the wild, and I'll generalize this by calling my counter variable I, which is also common convention. So we could do the following. I could say for, open my parentheses, int I is equal to 0. This is going to initialize my counter variable. And then I'll do I is less than 4, because I want this loop to do something 4 times. And then at the end here, I'll increment my I variable. Now I'll open some curly brackets, and inside here, I think I can just print out a single question mark. So let's save this, and we'll come over to our terminal. We'll compile this with gcc-o mario.c, and let's try running this. And well, this is kind of working. We're getting our 4 question marks, but I forgot my new line. So my prompt is on the same line. So let's go ahead and fix this. We can come back in here, and inside our quotes, we can just add \n, save. We'll come back, recompile, rerun, and And so this is just to say that the computer is going to take you very literally. So what's going on here? Well, we know that this loop is going to run 4 times. And on the first pass, or the first iteration of this loop, we're printing out a single question mark, and then a new line. And then this loop's going to run again. And it's going to print another question mark, and another new line. So you can see how this is going to kind of draw a vertical bar, instead of a horizontal bar like we wanted. So where does this \n need to go? It's not here. Well, I would argue that it needs to go at the end of our loop. After our loop finishes, then we want the new line to appear. And to do that, we can simply say printf and just print a new line. Because again, the new line is just a character. So I'll make sure to save this, and then let's come back to our terminal. We'll recompile and rerun, and now we get our 4 question marks, followed by our new line. And although this is more code to write, I would argue that this is better designed, because now if we wanted to print, say, 10 of these question marks, we just change this one number. We save this, we'll come back, recompile, rerun, and there's 10 of them. And if we wanted 50, we could just come back in here and change the number. But now what if we wanted to draw, say, a column like this? Albeit not using graphics again, but let's just represent each of these blocks with a hash symbol. So how would we do this? Well, we kind of already saw this. We could come back in here, we'll change this to a hash, and we want to print 3 of these. However, we want to add that new line right here instead of at the end of our loop. We want the new line to happen after we print each one of these hashes. And if we save this, come back to our terminal, recompile, rerun, you see we have this kind of textual representation of that column of bricks. So now that we've seen how we can draw these kind of one-dimensional horizontal or vertical bars, representing them using hashes or question marks like this, so how would we draw something more two-dimensional? Something like this, which is really just a 3x3 grid. And if you think about it, a 3x3 grid is really just 3 rows, and each row has 3 boxes, or 3 hashes. So I'll come in here and I'll clean this up really quick. And let me just ask the question. How many times is this for loop going to run? 3 times, right? It'll do something 3 times. We haven't told it what we want it to do 3 times. All we've told it is that we want this for loop to do something 3 times. So how would I print out a row of 3 hashes? We've already seen something similar when we just wanted to print out 4 question marks. So if I wanted to print out 3 rows, and each row has 3 hashes in it, then I can do something like this. I can say 4, int j is equal to 0, j less than 3, j plus plus, and then inside my curly brackets, I'll print out a single hash. And then after this inner loop is done, I want to print out my new line. I'll save this, open my terminal, I'll come in here, recompile, and rerun. And you can see that we get this grid. So let's go back to this code and break this down a little bit, because I know this can seem confusing. On this line, what are we doing? Well, we're doing something 3 times. And the first time that this loop runs, what are we doing? Well, we're doing something else 3 times. And the first time that this inner loop runs, what are we doing? We're printing a single hash. And then this loop is going to run again. We're going to print out another hash. And it'll run for a 3rd time, and it'll print out a 3rd hash. And then after this inner loop finishes, we're going to print a single new line. So this is going to look like 3 hashes and then a new line. And then what's going to happen? Well, this outer loop just finished its first iteration. On the second iteration, it's going to do the same thing. It's going to run this for loop 3 times, this inner for loop, and it's going to print out 3 hashes followed by a new line. And this is going to look like this now. And then again, on the final iteration of this outer loop, the inner loop is going to run 3 times, printing 3 of these hashes, followed by a new line, which would look like this. Then this outer loop is going to finish, and we're going to exit our program. And it's just convention when using these nested loops that if you're already using the variable name I in the outer loop, most programmers will just default to the variable name J in the inner loop. Why? Just because J comes after I in the alphabet. But it would also be reasonable to call this inner loop something like row, and this outer loop something like call, or for column. And then we would just have to change our variable names in these other areas as well. And I would argue that this would make this program a little better designed. I'm sorry, this should be row. And this is an example of how we could use nested loops, these loops inside one another. And again, I know this syntax can look strange, but if you break it down line by line like we did, it starts to make sense. This outer loop is going to do something 3 times. And each time, we want to do something else 3 times. And I'll ask some questions now. Is this program correct? Will it print a 3x3 grid of hashes? Well, yes, it is. Now, is this well designed? For example, what if I wanted this to print a 5x5 grid instead? What would I have to do to make this change? Well, I would have to come up here to this 3, I'd change that to a 5, and I would come down here to this 3, and I would change that to a 5. So 2 places. Not a big deal, but we can do better. If we always want this to print a square grid, for example, we could extrapolate this out to a variable. I could come up here, and I could give myself a new variable. It's going to be an integer, and I'll call this n for like the number of hashes. And I can assign this the value 5. And now down here, I could use n in this spot and n in this spot. Now, if I ever want to change the size of this grid, I can change this one single number from a 3 to a 5 to a 50. So just as an example, let's change this to a 10. We'll save this, we'll compile this, and we'll rerun it. And we see we get a 10 by 10 grid now. So this is working how we expect. But there still is one slight optimization that we can make here. It turns out that we could still screw this up. If at some point in our code we changed the value of n, for example, if we did n is equal to 20, then obviously this is going to print a 20 by 20 grid instead of a 10 by 10 grid. So what we could do is we can make this n variable a constant. And a constant is just a variable whose value can never change throughout the program. And to do this, we just prefix this with the word const. And this is what's known as a constant variable. It's constant in the fact that now if we tried to say something like n is equal to 20, you can see we're getting this underline. And it says expression must be a modifiable value, meaning we cannot modify n. And it's also best practice to capitalize your constant variables. However, since we did that, we also need to use capital N down here and a capital N down here. And this is an example of defensive programming. When we write code, we want to make it difficult for us to make mistakes when we can. And constant variables, again, cannot be changed once they are defined. And I would now argue that this program is better designed in the sense that I'm using this constant variable, so n can never change throughout my program, and I'm using these nested loops that take care of printing out my grid. And if I ever want to change the size of this grid, I can change this one value, recompile, and we're done. Lastly, n up here isn't a very descriptive variable name, so I should probably give this a better name, something like grid size. Makes a little more sense. And then I would have to change this here also. And now I would argue that this is a better designed program. But let me ask a question now. Wouldn't it be great if we just had a function, kind of like printf, that just took some numbers input and printed a grid? Like if instead of all of this code, we just had a function like print grid, and we could pass it a number like 5, and it would print us a 5 by 5 grid. We wouldn't have to care about how print grid was implemented. All we would really need to know is that it takes 5, or really an integer, as input, and as output, it's going to print us a grid of that size. That would be pretty great. But unfortunately, the inventors of C didn't implement a print grid function for us. So how could we define our own print grid function? In the next video, we'll pick up where we left off here and see how we can define our own functions, like print grid. And we'll also talk about this main function that I've been avoiding up till now. Thank you all so much for watching. I really hope you got some value out of this video. I know nested loops can be pretty confusing and intimidating, so please post your questions in the comment section and play around with these. The best way to understand this is to try it yourself and experiment with them. Maybe try prompting a user for how big they want this grid to be, or create 2 variables that lets you print a rectangular grid. Anything you do on your own time is only going to benefit you in the long run. If you enjoyed this video, make sure to hit the thumbs up so that I know you want to see more content like this in the future. And I'll catch you in the next video.